Okay. Now, today we will start with Lesson 7, Chapter 7, Lesson 7. Now, Lesson 7, its title is Exponential Growth and Decay. I'm talking about exponential function. I'm still talking about exponential function, but here now with two types of them. It could be growth, exponential growth, or exponential decay. Now, for the exponential growth here, look at the first graph. Like, as I will tell you here, the exponential growth, it's like you have its function, or its exponential function that we know it before. It's the initial term times the base b raised to x. This is an exponential function. Now, if b now, this one, is greater than 1, I will say it is a growth.
Teacher?
Yes?
Teacher, are you sharing a screen?
Yes?
I can't see it.
All of you?
No, miss, I can see it.
I can see it.
I can see. I can see it.
Okay, so Yara, I think the problem is from your laptop.
Teacher,
Or
I'll
internet.
go out and come again.
Yes, okay. I'm waiting you. Okay, so this is my exponential function a times b, where's b or the base raised to x. Now, if b is greater than 1, I will say it is an growth. But if b is less than 1, but greater than 0, I mean it must be positive. And in decay, now in decay and in growth, both of the bases, it must be positive. But 1 is greater than 1, but the growth is greater than 1, and the decay it's less than 1. Now, I will give you an example how the exponential growth will be. Like, if the teacher told you at the first day, bring 2 pencils. The second day, she told you have to double them. So you bring 4. The third day, you double them. So you bring 8. The fourth day, you double them. So you bring 16. As you see from here now, the numbers are increased. The first day, I bring 2. The second day, I doubles them. I doubled them. It will be 4. The third day, I doubled the 4, which will be 8. So here my numbers are growing, So because of that, I will say it's an exponential growth with y equal a times b, where b raised to x, and the numbers here, as you see, it's getting bigger. It starts with 2, then 4, then 8, then 16. So it's getting bigger. But in the second one, my mom gave me, at the first day, she gave me only half reals. And then she told me at the second day, I will give you half of the first day. She will give me 1/4. The third day, she will give me half of 1/4, which is 1/8. And the fourth day, it give me 1/16, and then 1/32. So, did my, now, the money that I have in the 5th day, it's greater or less than the 1st day?
Less than.
It's less than. So this is a type of decay. Growth, the number at the last day is greater than the number on the 1st day. So it's a growth. As you see at the, if you look here at this one here, it's a growth. It's started with a very small number, then it's growing until infinity. But in the decay, I started with half, I started with a great number, a big number, then it will be decrease. This was a exponential decay. Now the second thing I want to tell you, be careful. The exponential function cannot intersect the x-axis. It only approaches to it, but without crossing it. And I mean that it cannot be like this. It cannot crossing it, or it cannot intersecting it. It must only approaches to it, like this one here. Like this is I function. It's like this. It can intersect the y-axis, but it cannot intersect the x-axis. It approaches to it, but it cannot be 0. So this is now the main idea of our lesson, the exponential growth and the exponential decay. Now let's now talk about the exponential growth. The exponential growth now can be modeled by the function a times b, where b is raised to x. It is like any function. It's like the exponential function. A, where a is an initial term, and b is the base raised to x. Now, be careful here. A must be greater than 0, and b is greater than 1. B here, it must be greater than 1, like it must be 1.32, 1.47, 2, 4, 8, any number, 1.005, any number, but it must be greater than 1. If the b of the base is greater than 1, so it is an, I'm talking about growth factor. Because this b here, I will name it as the growth factor, which equals 1 plus the percent rate of the change expressed in a decimal. So I mean that from here now, I want you to know that the growth factor b must be greater than 1. B must be greater than 1. This is for a growth factor. It must be b is greater than 1. Now back here now, this is now my function. Why? In both decay and growth, they have the same function, a times b raised to x. What is a? A, it is an initial amount. It is the first number or the first amount that I will start from it. And b now is the base, which is greater than 1. I will name it with a growth factor. Look at the graph here. The number is increased, as you see from here. The number now is increased. So I say that it is an exponential growth. Now, Identify the initial amount A and the growth factor B in each exponential function. Look at here now. G of x is 14 times 2, where's 2? X. So here now, I'm sorry. Here now is an initial amount. And the number which is raised to x is the growth factor. Look at it here. Is it greater than 1? This 2, is it greater than 1? Yes.
Yes.
So I say it is a growth factor.
Factor.
Now look at number 10 now. Here now, this is what is 150? Is it a growth factor or it's an initial amount?
Initial amount.
Yes, it is an initial amount. Look at this one here, the number what that it's raised to x, it is 10894. Before that, is this number is greater than 1?
Yes.
Yes. So, because of that, I can say, oh, sorry. I can say now that this number is a
Growth factor.
growth factor. Now, what happened here?
Miss, before you start with the
How did
other
you know that 2 is greater than 1? Yeah, I mean that 2 is a growth.
Here, look at 2. I will ask myself, is 2 is greater than 1?
Yes.
Yes, so it's a growth factor. It must be greater than 1.
Because it have the variable, so we see for this.
Yes, exactly. Yes, I will look. Okay. I will repeat this one here. How can I know which one is the growth factor? I will look at which number has raised to x, 2 or 14?
2.
2, exactly. So because 2 is the number that is raised to x, so this will be a factor. Now I want to check now if this factor is a growth or decay. Decay, until now I didn't talk about it. Just look. Is 2 is greater than 1?
Yes.
Yes. So I can say it's a growth factor.
Okay, thank you.
You are welcome. Then what about 14 here? Is it raised to x?
No.
No. So I will say it is an initial amount.
Stop, teacher. I have a question.
Yes, Farah.
Teacher, for the initial amount, it must be greater than 0
Yes.
to be a growth.
Here, as from here, where is it? A must be greater than 0.
Okay, means we check the initial amount and the growth factor. Yes?
Yes.
Okay.
Okay, now let's start with problem number 1. Here now, we have a word problem. This word problem, I want to write the exponential growth function, how it will be. Look at this one here. Since 2005, the amount of money spent at restaurants in the United States has increased. Look at this word. What is it? It is increased. So in the word problem, if you see a rate, a percent rate, which is 7%, and before it you have a word increased, so I'm talking about exponential growth. Okay? If you see now
Okay.
a word increased, then you have a percent rate, so I'm talking about exponential growth. So here now I have the rate R, or the decimal number, which is 7 of the percent, 7%. Then in 2005, about 360 billion was spent at restaurants. So look at me here. Before I'm talking about the growth, here you have 205, 206, 207, and so on. In 205, the initial amount of dollars that they are spent on the restaurants are 360. So here, the initial amount of dollars that are spent in restaurants in 2005 are 360. In 2006, it will be 360 plus the percent rate, which is 7%, multiplied by 360. I mean that the first one is 360, then it's increased by 7%. That means it's the first year I spent 360, the second year I spent 360 plus 25, so I spent 385. Then in the third year I spent 385 plus 0.07 plus 385. I multiply by 385. That means here the number is increasing. So I say it's a growth. So how now the function will be? Look here now. The function is y equal a, the initial amount, times the growth factor raised to x. Where's the initial amount that I pay it or I spent it at the first year? They are 360 times. What is now the base? The base here is a growth. Base here is a growth factor. Now, if I'm talking about the growth factor, so the base here, it will be 1 plus r. Every time, if I'm talking about exponential growth, I'm talking about 1 plus r. Where's r here? It is 7%. 7%. If I want to write it as a factor, it will be 7 over 100. As a decimal, look at me, what I have to do here. Here, how many zeros did you have? You have 2 zeros, so you have 2 digits. Then, let's take 7, start from here. Put 7 here, then here you have to write 0. So, 7% is 0.07. So, my percent rate as a decimal is 0.07 plus 1. Here, I must add 1. If I'm talking about growth factor, I must add 1. So here the base now, it will be 1.07 raised to x. Now what is y? Y, it is the annual amount spent in restaurant after a specified numbers of years. This is a y. What is a? It is the initial amount spent, which is 360. At the first year, I spent $360. So this is my initial amount. Now what about the growth factor? The growth factor must be 1 plus the percent rate. It's a rule. If I'm talking about growth factor, I just add 1 plus my percent rate. So by now, I write my exponential function. It is y equal, I know that from the previous lesson, y is equal a times b raised to x. Now, go back to my question. And since 2005, the amount of money spent at restaurants in the United States has increased about 7%. Increased. I want you now to learn how can you analyze the question. Now, it's increased, so I'm talking about growth factor. In 2005, I'm talking about the first year, which is in 2005. Look here, I'm talking about from since 2005. In 2005, they are the same year, so this will be A. A can be defined. B, it's very easy. I just take the percent, the percent rate I have, and add it to 1. I have now B. Now, after that, so this is my function. If the trend continues, about how much will be spent at restaurants in 2015 now. So this is what now? I can find x from it. So why I want to find how much or how much money that you will spend on the restaurants in 2015. I say it's 360 multiplied by 1.07, and I have to find x now. What is x? X is the number of years since 2005. Be careful here. I'm talking about since 2005. I'm not starting with 0. I'm starting with 2005. Like when you born. You born in, I'm talking about myself as an example. I'm born in 1990. Okay? Now I'm in 2020. I want to find how old I am. I just subtract 2020 minus 19, so I am 30 years old. It is the same. You have to find how many old or how old is the restaurant as an example.
10.
So what I have to do? What is the last year now? I am now in 2015. And my initial one is 2005. So how many years now? Subtract them.
10.
10. Thank you. So now instead of x, write 10. Until now. Did you know from where I bring 360?
Yes.
107
Yes,
and 10.
Yes.
Thank you.
Yes.
Okay.
teacher, I don't understand the part of 107.
Part of 107. Okay. This is B. B is a growth factor. If you want to find the growth factor, you must add 1 plus the percent rate. Where's the rate? It's 700. But I will not add it as a rate, as a percent. I have to convert it to be as a decimal. If you have 7 over 100, I want to write it as a decimal. Look at me what you have to do. How many zeros did you have? 2 zeros. Then, what is the number here? It is 7. Let's start now to fill the blanks from the right. Here you have 7 only. So what I have to do, I will add 0. So 700 is 0.07. So instead of R here, I must write it but in decimal number. It's a growth factor. I must add 1. If I'm talking about later on, I'm talking about decay factor, I just say 1 minus the percent rate. In growth factor, I say 1 plus the percent rate. So which will be 1.07. Then after that,
Thank you.
you are welcome. So 1.07 raised to 10 is 1.96 multiplied by 360. So I spent $708.1 at 2015.
Miss,
Yes?
1.96. How did you bring it to multiplied 1.07 10 times?
Yes.
Okay.
I found it by calculator. Here it's 1.07 raised to 10. Then it's 1.96 multiplied by 360. You will get $708. So at the end of 2015, I spent $708 on my restaurant. At 2005, I spent 360. But in 2015, I spent $708. Now, what is an
Teacher,
expression? Yes?
will this lesson be in the quiz?
No.
Okay.
Now, what is an expression that represent? Did I record?
Yes, teacher, you recorded.
Okay. Now, what is an expression that represents the equivalent monthly increase of spending at United States restaurants in 2005? Here is now asking me about the expression that represent the equivalent monthly increase. Here, I'm talking about 2005, 2006, 2007. So I'm talking about yearly increase. But here now, I'm talking about monthly increase. So how can I find now the rate of the growth factor? Look at me here. What is the base or the growth factor here? It is 1.07.
Yes.
Okay, so my growth factor is 1.07. Now, this is 1.07 raised to x. And x here is what? is the number of the years. I want them now, but in monthly increase. Look at me. Take 107 as it is. Then this x. What about x now? It is in month. I want it in month. Who can tell me how many months in 1 year?
12.
5 months.
12. Thank you.
12.
So multiply by 12, divide by 12. So I have here to multiply x. Here I have x. This x, the first term multiplied by 12, divide by 12. It just like cancel each other. It's same x. Then after that, if you know that 3, look at me here. If you know that 3x over 3, can I write it as 3x multiply by 1 over 3? Is it the same?
Yes.
Yes. Here is, I have to do the same now. 12x over 12, I can write it as 1 over 12 times 12x. Like here, 3x and 3 is 1 over 3. Here is the same. 12x, I will put it outside, and 1 over 12, I will put it inside and keep 1.07 as it is.
Again, miss, this 12x divided by 12, it is the same for 1 over 12 to the power of 12x.
Yes, let's here now try to multiply them. If you multiply them, what you will get? If I have a number that's raised to a power, then it's raised to another power. I have to multiply them. 12x.
Yes.
If you multiply them, you will get 12x over 12. That is as the same as here. So just rewrite it. Yes, just now here, I want you to rewrite it to be as 12x outside the brackets and 1 over 12 is inside the brackets. Then after that, 1.07 raised to 12. Using calculator, (1.07) raised to 1 over 12 is 1.0056. This is only 107 raised to the power 12. I can write it as 1.0056. Okay, then this one.
Is 5.7 or 5.6?
Can you repeat?
It is 5.6 or 5.7 here in the number 1.00.
It is 1.00565. So if you round it, it's going to be 1.0057.
Yes.
Just by rounding. Now, so 1.0056, it is 1.07 raised to 12. And then after that, 12x, it's mean the monthly increase. I didn't want it to be as 12x. Keep it as m, whereas m is the monthly factor, or monthly growth factor. Is it clear now? I will give you more examples. Inshallah, it will be more clearly. But until now, I just bring the growth factor raised to x. I make it as 12x over 12. Then I will distribute 1 over 12 inside the brackets and 12x outside the brackets. Then find the answer. Then raise, but instead of writing 12x, write it as m.
Teacher, why did we put both of them? Like, why did we put 12x over 12?
Here now, I'm talking, he asked me to find the monthly increase. How many, so, but here x now is yearly. Because I wanted a monthly. How many months in 1 year?
12.
They are 12. So I just multiply by 12, divide by 12. Why? Because if you cancel them, it remains x. So I didn't make any change with my number. That's why I multiply with 12 and divide by 12.
Thank you, teacher.
You are welcome. Now let's do, yes?
12x. How did you make it month? Yani 12x is the number of months. So we simplify it for m to m.
Rename it with m.
Yes, okay.
Now, let's do get it one. Suppose that in 1985, there were 285 cell phone subscribers in a small town. So, the first year is 1985. The initial amount is 285. So y is a times b raised to x. A now is 285. The number of subscribers increased. What does it mean increased? They're talking about
Growth
thank you. I'm talking about the growth factor.
factor.
So, ya Allah. Increased, I'm talking about here now and growth factor. Why, what is the percent here? It is
75.
75. So, this is A, it's fine. I have to find B now. B now is 1 plus, what is the percent rate? It is 70%.
70%.
Let's write it. 70%. It means 75 over 100. Is it right?
Yes, 0.75.
Yes.
How many zeros here we have? 2 zeros. That's mean 2 digits. Then let's have 75. Right, 5 here, start from here. And 7 here. So what is my percent as a decimal now?
0.75 plus 1.
So the base here is 1.75 raised to x multiplied by 285. This will be my function. So y now equal 285 times 1.75 raised to x. Then, after that, how many cell phone subscribers were in a small town in which year?
1994.
1994.
1994.
So how can I find x? X is the number of years since 1985. So just here, put 1994 minus 1985 it will be 9 years. So here x will be what now? 9. So y is 285 times 1.75 raised to 9. One 1.75 raised to 9 is 153.9. Multiply by 205. Don't forget, the first time you have to find the exponents, the number that's raised to power, then multiply by 285. Okay, don't multiply 285 by 1.75. The first time, do the exponential. Remember the bit mass, the order of operations. So 153.9 multiplied by 285. And the answer is subscribers by the end of 1994.
It is plus 153.9 or multiply.
Multiply.
Okay.
Now, the second thing, write an expression to represent the equivalent monthly cell phone subscription increase. The same steps before. Take 1.75 raised to x. Rewrite it as, who can tell me? I want it in monthly increase.
It's gonna be 12 again.
Excellent. 12x over 12. Then the same steps. Put 1.75 raised to 1 over 12. Then raised to 12x outside. Then 1.75 raised to, and using calculator. 1 over 75 raised to 1 over 12 is 1.04 raised to 12x. But I want it now, or I want to rewrite it now, an expression but in monthly cells. So I will say it is 1.04 raised to m. So if he later on tell me as an example, find the subscribers in June as an example, after 6 months, just say y equal 285 multiplied by 1.04 raised to 6. This is not as an extra, okay? It's not from your book. He will not ask you in monthly. He just ask you to find an expression in monthly increase. Is it clear now?
Miss, you made
Yes,
1.75 to the power of 1 over 12.
Yes, I will get 1.04.
Any number that you made it 12 times, or 12 times to give you 1.75, you made it like this.
Can you repeat, please?
I mean, teacher, from where brought 1.04? What is the method that?
Okay, using the calculator, put 1.75 raised to 1 over 12. Did you know how can you find or how can you raise a number to the base by using a calculator?
No.
Okay. I will make us a video. Okay, and just I will just send it by WhatsApp, or I will open it here to let you how to find the power of the base. Okay?
Okay, thank you, teacher.
You're welcome. By the way, are all of you in with us on the WhatsApp group?
Maybe. I didn't.
maybe I
see
did.
that.
Teacher, which WhatsApp group?